Hi everyone, welcome back to the channel. Be sure that to subscribe to our channel by clicking on the subscribe button. Today I'm going to cover chapter 2, Chemistry of Life. Let's get started. So we have two big goals. Big goal number 1, students should develop an understanding of basic chemical principles affecting living things. And big goal number 2, they learn the structure and function of atoms, elements, compounds, and molecules. Okay, so matter, which is made of the chemical elements, is a pure or compounds, is a combination. Elements properties depend on their structure of their atoms, chemical bonding between the atoms, and chemical reactions make and break chemical bonds. Okay, so periodic table. So the organisms composed of matter, which takes up space and mass. There are 118 plus known elements, but 94 of them actually naturally occurring elements. 24 of them are lab-made. Each has a unique symbol and basically one or two letters of their name from Latin or German. So number of electrons in highest occupied shells. You can see here they are designed in the different shells and groups starting 1A to all the way to the group 8. Okay, so life required 25 chemical elements. Carbon, hydrogen, oxygen are the 4 big ones, make up 96% of the living matter. The rest of the 4% are phosphorus, potassium, calcium, and sulfur. Okay, so they are highlighted here in purple and colors. Trace elements are the other group, which is only requiring in minute quantities. That's why it's called trace elements. Iron is one very important one required by all organisms. Others required by maybe some species. They, for example, another important one, iodine, which daily intake of 0.15 milligram iodine required for normal activity of human thyroid gland. And iodine deficiency may result in boiler in growth, like you see here in this picture. So elements property depends on their atoms. Atoms are, each element consists of unique atoms. That's why they are specific elements. That's the smallest unit of matter, still retains the properties of the element. Atoms composed of subatomic particles, right? Protons, neutrons, and electrons. So you know that. Okay, so atoms have protons, neutrons, and electrons. The protons located in the nucleus, and then they might combine masses to get atomic mass, and electrons located in the electron shells. Okay, atomic number and atomic weight. Atomic number is the number of protons. Atomic weight is basically protons plus neutrons number. That's why atomic weight or mass number is bigger than atomic number. Isotopes, so there are sometimes two atoms of the same element, they only differ in their neutrons. So example, 99% of the carbon atoms are carbon-12, they have 6 neutrons, but 1% of the carbon atoms are 7 neutrons, they are carbon-13, and very rarely there is carbon-14 with 8 neutrons. Okay, so that divides all the isotopes in two groups, stable and unstable radioisotopes. Stable isotopes don't lose their particles. They stay as they are. Unstable ones, they decay and they lose particles and then they emit particles and energy. So electrons have these shells, potential energy levels. Their energy actually depend on their location. The farther away from the nucleus, the more potential energy they have. Okay, you can see here first shell, second shell, third shell, much higher actually here energy. Okay, so electrons can actually move back and forth between these shells by absorbing or releasing energy. Okay, so chemical behavior of elements actually determined by electron configuration of this distribution of electrons in electron shells. Okay, you can see here, first shell has only one shell here, second shell, 2 shells, third shells, 3 shells here. Okay, The most important shell is this valence shell, outermost shell. That's where we focus on. Atoms combine by chemical bonding to form molecules. So atoms with incomplete valence shells more interactive by sharing and transferring valence electrons. These typically result in chemical bonds. Some strong bonds are covalent, ionic, but in crystals. Some weak bonds, hydrogen, van der Waals, and ionic again, but only in water. Okay, covalent bond, of course, sharing. It's about the sharing of the pair of valence electrons by two atoms. Here you see in this case, two hydrogen atoms sharing their electrons, and they become H2 with a covalent bond here. Okay. Electronegativity is about the atom's ability to attract, hold, the share electrons more stronger. So there is an order of electronegativity, like fluorine is 4, oxygen 3.5, nitrogen 3, but hydrogen is only 2.1. So strongly electronegative atoms pull share electrons towards themselves more. Okay. So nonpolar covalent bonds, atom shares electrons equally. So there are also single bonds, double bonds, triple bonds, depending on the molecule. Ionic bonds are actually more stripping the electrons away from the partner. And the best example is sodium and chlorine. Sodium has 1 extra electron in their outer shell, and chlorine has 7. Chlorine needs 1. Sodium willing to give away 1, and they actually do that, and they become sodium plus ion and chlorine minus ion. We call plus ions like this cation, and negatively charged ions anion. And the bond that between them is now ionic bond. Hydrogen bond is a very common bond, even though it's weak bond. To form when a hydrogen atom covalently bond to an electronegative atom, also attracted to another electronegative atom. You can see here the dotted hydrogen atoms. Okay, van der Waals interactions are more attractions between the molecules. We see that in these geckos' toe hairs, that around 500,000 hairs, they can actually walk on this surface by hanging on the wall using this just one toe, possibly. Okay, so molecular shape basically determines how biological molecules specifically recognize and respond to one another. So example here, this is natural endorphin, and this is morphine, which is basically their shape is very similar to each other. And then here they can actually bind to the same receptors in the brain. So, and the chemical reactions can make and break the chemical bonds. There is reactants, there is a reaction, and there's products. And chemical equilibrium is when they are reached, when the forward and reverse reactions occur at the same rate at equilibrium. And this concludes our chapter 2 video, and see you in next